Hi guys, this is Miss Wesley. We're going to talk about dilations today. So this is Unit 3, Skill 2, Part C. So I know it was a lot. So our essential question for today, and again, make sure you jot this down, is how do we dilate a shape given both the scale factor and the center of dilation? So again, I'll just repeat it. How do we dilate a shape given the scale factor and center of dilation? Both of those things are going to be important for you to know no matter what kind of dilation we are doing here. So I'm going to take you through some different examples, and hopefully by the end of this video you will have a good understanding of what dilations look like in geometry. So let's take a look at this first example. It says dilation centered at the origin. In the diagram below, triangle ABC has the following coordinates, A, B, C. Again, these coordinates here, I'm not reading them aloud. You can see that the triangle's graph below. It says graph and label triangle A prime, B prime, C prime, the image of ABC after a dilation with a scale factor of 2, and it's centered at the origin. So hopefully at this point you know that there's two keywords that you want to be familiar with dilation. Dilation is always either going to be a grow or a shrink. Getting used to my writing on this new iPad here, so bear with me. So dilation is either a grow or shrink. So the first thing I'm going to notice is that my scale factor here was 2. So since that 2 is greater than 1, my shape here is going to grow. It's going to get larger. All right. And the center at the origin means I'm going to put a dot here because that's going to be my point of reference. I'm always going to return to that point when I deal with my coordinates. So the first thing that you want to do is you're going to start one point at a time. So for instance, I'm going to start with A. From the center of dilation, which we know is the origin, right now I'd have to go up 1, over 1. Well, if I want to double that distance, again, I know I'm doubling it because my scale factor over here, ooh, that was weird, my scale factor over here is a 2. I'm going to simply go back and say, all right, if I went up 1 over 1, I'm going to do that one more time. Up 1 over 1, and that's going to be my new point A. So I'm going to put a dot there, and that's going to be A prime. All right. I'll show what I mean for point B. So right now, for me to get to point B, I have to walk up 1 and over 1, 2, 3, 4. Well, again, I'm going to double that, so I'm going to go up 1, over 1, 2, 3, 4. And I'm going to put a dot right there. That's going to be my new B prime spot. And the last one, C. So right now I have to go up 1, 2, 3, 4, 5, over 1, 2, 3, 4. So again, I'm going to double it. I'm going to go up 5 again. 1, 2, 3, 4, 5. We just make it over 1, 2. Oh, what happened there? 2, 3, 4. That's going to be my new C prime. And now if I connect those points, A prime to B prime, B prime to C prime, A prime to C prime. There's my new triangle there in green. So if I outline my original triangle, A, B, C, compared to A prime, B prime, C prime, I will notice that that triangle has in fact grown. And if, again, I checked my numbers here, I doubled all the sides, and again, I doubled them because my scale factor was 2, and they doubled their distance from the origin. So wherever your center of dilation is, that's where your shape is either going to grow or shrink from. So that was one example. I'm going to take you now through a second example. Alright, so here we are for example 2. Sorry, I just had to make a new slide out of that, but I'm still on the same page. And if you notice, it's the same exact picture we had before, triangle ABC, and our coordinates are still the same from what we had above. And this time it says graph and label triangle A prime, B prime, C prime. So again, we're given the same initial directions here. But notice it says the image of ABC after a dilation with a scale factor of 3. So my scale factor is different. And this time it says it's centered at point C. Ooh, sorry about that. Let's try that again. Centered at point C. So the first thing I'm going to jot down over here is that I know this is going to be a grow, again, because it's bigger than 1. And this time, my center of dilation is going to be C. So I'm going to put a point on C so I remember that that is where I have to focus around each and every time. So if we go through the same process that we did for the one up above, I'm going to start with point A. And to get from C to A, again, because you always go from your center of dilation, right now I'd have to walk left 1, 2, 3, down 1, 2, 3, 4. Well, this time around, I want to triple that distance. So again, I said I went left 3, down 4. Well, I'm going to do that again. Left 3, down 4, and then one more time to get 3 of them in there. Left 3, down 4. But this time I actually need to use it with my pen. So I'm going to go left 3, 1, 2, 3, down 1, 2, 3, 4. Now again, that would just be doubling it, so I'm going to do it one more time to triple it. 1, 2, 3, down 1, 2, 3, 4. So this is where, I'll make it blue this time, that's where my new point A prime is going to be. So let's go over and do B. Again, I have to count my original distance from the center of my dilation. So since C was my center, to get to B right now, I just walk down 1, 2, 3, 4. Well, I'm going to double it. 1, 2, 3, 4. But again, my scale factor was triple, so I have to do it one more time. 1, 2, 3, 4. And that is where my new point B prime is going to go. And you might be asking, well, Miss Wesley, what about C? Where's C prime? Well, if I'm dilating around C, C is going to stay right where it is. Because if it's on my center of dilation, I can't change it. It's just going to have to stay. So meaning that if I connect my new points now, A prime to B prime, and then I go up B prime to C prime, and I come back down, you'll notice, again, your original triangle got over, drawn over probably, but A, B, C was my original. And if I look at this shape, A prime, B prime, I should probably write a C prime up there. This shape is larger. It's specifically larger by 3. And my center of dilation was C, so C didn't go anywhere. So the only thing I'm going to add to my paper real quick is this is now also C prime. So that are those are two examples where I show you dilations, one centered at the origin, one centered at a point different than the origin. And we're going to take a look at the two examples in the back because so far we've only seen scale factors larger than 1, meaning grow. So now we're going to look at what would happen if we have a scale factor less than 1. Okay, here we are on the back of this page of notes, and we're looking at example 3. It's another dilation. So it says in the diagram below, rectangle EFGH has coordinates, and again, all these coordinates are written out here for us, and they're already graphed. Obviously, if you were given just the coordinates and no picture, you'd have to graph it yourself, but in this case, we can go ahead and just keep moving on. It says graph and label rectangle E prime, F prime, G prime. The image of rectangle EFGH after dilation, this time with a scale factor of 1/2, and this time it's also going to be centered at the origin. So again, I always start by putting a nice dot wherever my center of origin is, center of dilation is, so that way I know that's the point I'm going to refer back to each time. And since this is also a number over here less than 1/2, that means this is going to be a shrink. Uh-oh, I don't want to shrink my page. Let's undo that. There we go. It's going to be a shrink. All right. So we're going to follow a very similar process to what we did in the first couple examples. I'm always just going to start by figuring out, well, what is my distance for each point from my center of dilation? So right now, in order for me to get from the center of dilation to E, I have to walk up 1, 2, 3, 4, 5, 6, and over 2. Well, since I'm essentially going to cut that distance in half, instead of going up 6 over 2, I'm going to go up 3 over 1. I'm going to cut both of those numbers in half. Let's use purple here. So up 3 over 1, I'm going to put a dot, and that is going to be my new point E prime. Okay. If I was to do the same thing for H, H is in line with E, so I know I'd have to go up 6, and this time I have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 6 over 9. Well, I know cutting 6 in half will leave me with 3. If I want to cut the 9 in half, that's going to give me 4.5. So again, I'm going to go up 3 over 4.5. 1, 2, 3, 4 and a half. So my point should be right about there. So I don't get this too messy, I'm just going to put a dot there. So 1, 2, 3, 4 and a half. So it'd be right about there. Why does it keep doing that? H prime. All right. Let's do the same thing for F and G. So right now to get to F, I have to go down 1, 2, 3 over 2. Again, I'm going to cut both those numbers in half. So I'm really only going to walk down 1.5 because that's half of 3. And instead of going over 2, I'm going to go over 1. That's my new point, F prime. And again, if I follow the same idea for G, right now I'm going down 1, 2, 3. I'd walk over 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I'm cutting both those numbers in half. So I'm going down 1.5 over 4.5, because that's half of 9. 1, 2, 3, 4.5. It'd be right about there. There's my G prime. So if I connect those, I'll choose pink, I guess. E prime to H prime. And if I finish this rectangle, sorry, mine's not nice there. So that rectangle compared to our original rectangle that we have here, you'll notice that my new pink rectangle is definitely smaller. It was cut in half, and it was cut in half based on me standing at this point, the origin right here. So if you have any questions on that one, please let me know. Ms. Griffin or Ms. Davis know. But again, what I'm doing is I'm finding the distance to each point, and this time instead of doubling it or tripling it, I'm cutting those numbers in half to make it half the size smaller. So I'm down here in our last example, example 4. Again, like before, you'll notice that this is the same picture that we just worked on up at the top, but there's some different conditions set for us here. So graph and label, again, rectangle E prime, F prime, H prime, the image of rectangle EFG. This time it says after a dilation with a scale factor of 1/2. So our scale factor, happens to be the same, but this time we're centering it at E. So again, the very first thing I do is I'm going to go over my picture, put a nice dot on my center of dilation, so I always use that as my point of reference. And I'm going to make that mental note to myself that since my scale factor is less than 1, that means my picture should shrink. If it doesn't shrink, you did something wrong, you're going to go back and check your work. So I'm going to start with H. So right now from E to H, because again you always count the distance from the center of dilation, right now I have to walk 1, 2, 3, 3, 4, 5, 6, 7. Well, I want to cut that distance again in half. So if I cut 7 in half, 7 divided by 2, I'm going to get 3.5. So I'm going to take my marker, I'm going to walk over 3.5. 1, 2, let's try it again, 2, 3.5. I don't know what's going on, I apologize, guys. Come on, let me put a purple dot there. So that's going to be my distance right there. Hold on. Okay, hopefully I fixed it. So that's going to be my H prime. All right, now I'm going to count the distance to F. So if I start, again, at E, because that's my center of dilation, right now I have to walk down 1, 2, 3, 4, 5, 6, 7, 8, 9. So this time I have to cut 9 in half. 9 divided by 2, if you remember from up above, gives us 4.5. So I'm going to take my new marker, I'm going to go down 4.5, again, from my center of dilation. 1, 2, 3, 4.5. So right about there is going to be F prime. Now, because it's a rectangle, some of you might already be saying, well, Miss Wesley, I know where G prime is going to go, and that's great. I'm going to talk you through the process, though, just so you can have it in case it's not clicking just yet. So if I have to figure out how to get to G prime, again, I have to count my original distance from the center of dilation. So I know I have to go down 9, and I have to go over 7. And thankfully, I already cut both of those numbers in half from over here. So I know that I really should walk down only 4.5, because that was half of 9. 1, 2, 3, 4.5. I'm going to go over 3.5. 1, 2, 3.5. So I'm going to put a dot there. That's going to be my G prime. So now if I connect those, I know I got a lot of overlapping colors here. This is, hopefully your line is straighter than mine. That's my new rectangle. Again, it was dilated by 1/2, so my picture should have shrunken, and it did. It's definitely smaller. And it's all centered around E, hence why E didn't change, and I could just go back and label this now as E prime. So again, your overall procedure here is you have to first figure out where's your center of dilation and make sure you put a nice dot there because that's going to be your point of reference. Ask yourself, is your shape growing or shrinking? Is my scale factor bigger than 1 or less than 1? And then count the distance to each point from that center of dilation, and either keep doing that if your shape's going to grow, or cut those numbers in half if it's going to shrink. Maybe you even sometimes have to cut it in thirds depending on what the scale factor is. So definitely try your practice problems, and then when you're ready, go ahead and take your quiz. See you next time.